So we can see that every bit happened. It animates the hard picture in the OLED and count the bit. And after 15 seconds, the ppm is displayed. This is Adc Pulse Sensor. This sensor has ability to detect the cardiovascular pulse wave from a fingertip. It's a Ppg sensor. Ppg is photopeltimography. Photopeltimography. Did I spell it right? And Ppg means non-invasive technology that uses light source and photodetector at the surface of skin to measure the volumetric variations of blood circulations. In simple words, the output of this sensor varies according to the volume of blood in the tissue. So for example, when the heart is pumping the blood, it will make the blood volume in the hand is increased. So the light that is absorbed by the hand is increased, and the light that is received by the photodiode is less. We can see inside the sensor there is an LED and photodiode. When our finger is placed between, so the sensor actually reaches the light that is received by the photodiode underneath my finger. The sensor module comes with its signal conditioning, make it so easy to interface with an Arduino. And not just that, this module is also designed to easily fit an Arduino. So it's like a shield. Just plug and we are good to go. We can use any Arduino of course, but using Arduino Uno is easier since the size is matched. The sensor has two output pins, it's A0 and A1. We can set where we want to put the output by using this jumper. And the sensor are also compatible with 3.3 volt or 5 volt power supply. We can also set the voltage here. Now I will do an experiment on reading this sensor output and see what this sensor has. So I will use an example from Arduino IDE. It's called analog read. So this sketch is actually just read the IDC from the sensor and print to serial monitor. To analyze the output, I will use serial plotter. So I will put my hand inside the sensor and this is what happened. Now we can see that there is pulse detected by this sensor. The signal is pretty clear enough compared to some sensor that I ever used. Now since we're able to read the heartbeat pulse of my finger, now let's try to count them as beat per minute or BPM. Wait, before we continue the video, you can make me really happy by subscribing to this channel and tap the bell so you won't miss new video from me. But first, we need to determine the Adc threshold to count the pulse as a beat. So in this example, I will put the threshold at 600. So whenever the Adc reads more than 600, it will add the beat by 1. And I will make the lower threshold to reset the counter, so it will able to count the beat again. I will use the 500 as lower Adc threshold. So here's what I do. So every time the ADC reaches more than 600, I will count it as a bit. Then I will disable count by changing the count status to 1. So even the data is still more than 600, the program will not add bit again. And every time the ADC drops to less than 500, I will enable the count status again. And it makes when the ADC reaches more than 600, it will count again. And so on. And every bit detected, it will print bit detected and the amount of bits counted in serial monitor. We can't really wait a minute just to get the reading right, so I will just read the bit for 6 seconds and then multiply it with 10. It means that 6 seconds is 1/10 of a minute. So to get amount of data in a minute, I just multiply the value with 10. You can do your own experiment on how much time you need to get better reading. We got about 60 bpm and 70 bpm. But if we multiply with 10, the value we get always multiple of 10. So to make more accurate reading, we can add reading time. So for this example, I will change the reading time to 15,000 milliseconds or 15 seconds. So here's the result when I measure the bits for 15 seconds. To make it more interesting, I will add a LCD to display a reading result. So I connect the LCD like this. This is a catch to count the bit and display the result to an OLED display. You can download the complete sketch link in the description below. So we can see that every bit happened. It animates the hard picture in the OLED and count the bit. And after 15 seconds, the BPM is displayed. So this is the end of the tutorial on how to use Adc Pulse Sensor. Consider subscribing this channel to make me happy and encourage me to make more videos. Thank you.